Hello friends, welcome again, and today we'll be solving a problem related to nyquist plot. And here we have to find the nyquist plot. Here we have to draw it, and then we have to comment on the stability. Okay, so GSHS is 10 over s into s by 5 plus 1 into s by 10 plus 1. So let us call this GSHS as L of s. So L of s is now given as 10 over s into s by 5 plus 1 s by 10 plus 1. Okay, so what we have to do for plotting the nyquist plot, we have to map the entire right half of the s plane, and we have to include the j omega axis also. Okay, so let us first try to plot the part from j equal to 0 to j equal to infinity, which is called the polar plot. Okay, so for polar plot s equals to j omega. Okay, so now we can write L of j omega equal to 10 over j omega into j omega by 5 plus 1 into j omega by 10 plus 1. Okay, so if you write the magnitude of this is what you get. Okay, 10 over omega under root omega by 5 squared plus 1 under root omega by 10 squared plus 1. Okay, now you can see one thing here. The angle of L of j omega is equal to minus 90 minus 10 inverse omega by 5 minus 10 inverse omega by 10. Okay, so what you can see here is the polar plot starts from minus 90 degrees. Okay, because we have to put omega from 0 to infinity. Okay, so when you put omega equal to 0, you get a angle L of j omega from equal to minus 90 degrees. Okay, and when you put omega equals to infinity, so you get an angle minus 270 degree. Okay, so you can say that your plot starts from minus 90 degrees and it ends at minus 270 degrees. Okay, so this is 0 and this is minus 90, so it starts from minus 90 degrees. Okay, and it ends at 270 degrees. Okay, minus 270 degrees, so it is like this. Okay, again what you can do is you can find this point. Okay, this point is minus 180 degrees. Okay, so this is at phase crossover. Okay, so what you can do is you can find this point. Okay, this angle is minus 180 degrees, so this is at phase crossover this point. Okay, and if how you can find it is you can equate this angle to minus 180 degrees. Okay, so when you equate it to minus 180 degrees, what you get is you get your omega as 50 under root 50. Okay, so you get your omega as under root 50. So at and when you find the magnitude at that point, you get 0.314. Okay, so this is the point minus 0.314. Okay, so now we have plotted the polar plot. Okay, and you have to remember now one thing, that the my 0 to minus infinity part is going to be the mirror image of this part. Okay, so simply if you want to now do this part from minus infinity to near to that 0 part, then this is just the mirror image of that. Okay, so this part I have just made the mirror image of that along real axis. Please remember it is along real axis. Okay, so this is how it is done. Okay, for now we have just mapped our j omega axis except for the point uh, 0 minus to 0 plus. Okay, so this point is not mapped till now. Why? Because here we have 0 we have a pole at s equals to 0, so we have to take some precautions while doing it. So for now we have just detoured that part. We have not included s equals to 0 here. Okay, now we will try to map our r e power j omega or our s when as r tends to infinity. Okay, so any point on this curve, okay, or on this path, on this contour, so you can see here that this r is going to be very large. Okay, this r is going to be very large. Okay, so what you can do is first we have substituted s equals to r e power j omega. This is just the polar form of s is equal to sigma plus j omega, but it can also be written as r e power j theta when you write it in polar form. So this is written in polar form. Now you can say that that is equal to 10 over r e power j theta into r e power j theta by 5 plus 1 and r e power j theta by 10 plus 1. Now what you can comment here is, as r tends to infinity, okay, this r e power j theta by 5 will be very large compared to 1. So you can put this entire term as r e power j theta by 5. Same thing you can argue with r e power j theta by 10 plus 1, which is nearly equal to r e power j theta by 10. Okay, so when you do all the substitution, what you get is L r e power j theta is equal to 10 over r e power j theta into r e power j theta by 5 into r e power j theta by 10. Okay, now as r tends to infinity, this r is going to be very large. Okay, so the this entire thing is going to be very small, so it's going to be 0. Okay, so this entire r e power g theta as theta tends to as r tends to infinity is mapped to 0. Okay, so this entire part is mapped to 0. Okay, now we are only left with this part from 0 minus to 0 plus. Okay, let's see how we proceed for this. So when you are going from 0 minus to 0 plus, again what you can do is you can again substitute s equals to r e power j theta, and then now you can see here that r will be very small, r will be nearly 0. So r e power j theta by 5 plus 1 will be where this part r e power j theta by 5 will be very small compared to 1. So you can put this nearly equal to 1. Okay, same thing you can do with r e power j theta by 10 plus 1 term, which will nearly be equal to 1. Okay, that's what I've done here. So when you do all that substitution, what you get is you are only left with 10 over r e power j theta. Okay, because this part, okay, this and this goes to 1. Okay, now when you write this, it becomes 10 by r e power minus j theta, or in pole of form you can write it as 10 by r angle minus theta. Okay, now you know that when you are going from minus 0 to plus 0, your theta will go from minus pi by 2 to pi by 2. Okay, and your r will be going from r will be nearly 0. Okay, so now your magnitude will be magnitude of this term. Okay, magnitude of this term, okay, or you can say this term will be very large. Okay, it will be infinity, and your angle is going to be minus theta. Okay, so when theta is going from minus pi by 2 to pi by 2, then your minus theta will be from pi by 2 to pi by 2 to minus pi by 2. So your curve will go from minus pi by 2 to pi by 2 as you go from minus theta to plus theta. Okay, so when you go from minus theta to plus theta, your curve will go from from pi by 2 to minus pi by 2. Okay, that's what is written here. Okay, now once you are through, you have got the entire polar plot now. Okay, now sorry, entire nyquist plot now. And now what you have to do is to comment about stability. Okay, for stability, you need to see the number of anti-clockwise encirclements of -1. Okay, so you can see here that it's not encircling -1 because this is minus 0.314. Okay, so you can say here that it's not encircling -1 at all. So n equals to 0 here. Okay, also p are the number of open loop poles which are lying on the right half of the S-plane. So you can see there all the poles are lying on the left side, or they are on the j omega axis. Okay, none of them is on the right half of the split. Okay, so that is also 0. Now z will give you the indication that how many closed loop poles will lie on the right hand side. So you can use this relation n equals to p minus z, where you can substitute n and p and you can get your z. So you can see here that n and p both are 0, so z is automatically 0. So hence there is no pole lying on uh, RHP right hand side, and this is closed loop pole. Okay, closed loop pole lying on the RHP. So the system is stable. Okay, so this is how you need to solve for the problem, and this is how you need to plot the nyquist plot. So thanks for watching.